Imagine standing on a shore, looking out at an ocean, but it's not water, it's lava. Molten rock, glowing an angry red-orange, flowing and moving just like water. It has waves, it has tides. But instead of crashing onto a sandy beach, these waves are 2000 degrees Celsius, hot enough to vaporize you instantly. Welcome to the lava worlds, planets with global magma oceans. And they are far more common than you might think. Believe it or not, nearly 50% of all rocky exoplanets discovered so far are capable of maintaining magma right on their surfaces. That's not a small number. That is half. Half of all rocky worlds we've found could have molten surfaces. Why? It's because most of these exoplanets orbit incredibly close to their stars. So close that a year on one of these worlds might only last a few days, or even a few hours. The heat from the star is just relentless, thousands of degrees, hot enough to melt rock and keep it molten forever. Let's start with a famous one, 55 Cancri e. It's a super-Earth, about twice the size of our planet, orbiting a sun-like star 40 light-years away. But 55 Cancri e is nothing like Earth. It zips around its star every 18 hours. That means it's 70 times closer to its star than Earth is to the Sun. The dayside temperature there rockets to over 2000 degrees Celsius, hot enough to melt rock. In 2022, astronomers created the very first thermal map of 55 Cancri e. What they found was shocking. The planet's surface isn't solid, it's molten. A vast, churning ocean of lava covers much of its dayside. And this lava flows, just like water, driven by the planet's rapid rotation and the intense heat of its star. As the planet orbits, lava flows from the scorching day side to the cooler night side. There, it might cool down, thicken, and maybe even solidify for a short time. But then, the planet rotates back into the star's glare, and the cycle repeats. An endless, flowing ocean of magma, forever circling the globe. Then there's Coro 7b, another super-Earth, about 5 times the mass of our planet, orbiting a star nearly 500 light-years away. COROT 7b orbits even closer than 55 Cancri e. A year on this world lasts only 20 hours. The dayside temperature is extreme, over 2500 degrees Celsius. That's hot enough to vaporize rock. And that's exactly what happens. The surface of Coro 7b is so hot that rocks literally evaporate into the atmosphere. You get silicate vapor rock in gas form. This vapor rises into the thin atmosphere, where it cools down just slightly and condenses into tiny droplets of molten rock. These droplets then fall back to the surface as rain. It rains molten rock on Coro 7b, not water, not ice, liquid rock, falling from the sky. Kepler 78b is another mind-bending example. It's a rocky planet about the same size as Earth, but it orbits its star every 8.5 hours. The surface temperature is over 2300 degrees Celsius. Kepler 78b is so close to its star that immense tidal forces are slowly ripping it apart. The planet is being stretched, heated, and vaporized. In just a few million years, it will be gone, completely evaporated into space. So, what would it actually be like to visit a lava world? Let's imagine descending toward 55 Cancri e. From space, the planet glows a deep red-orange, like a hot coal in the darkness. You can literally see the heat radiating from its surface. As you get closer, the temperature inside your spacecraft climbs. 500 degrees, 1000, 1500. The star above is a monstrous, blinding disk, taking up half the sky. There's no real atmosphere to shield you, just the naked surface below, glowing and molten. You descend further. Now you can see the lava ocean clearly. It's not calm. There are waves, massive swells of molten rock rolling across the surface. You see eruptions, geysers of lava shooting hundreds of meters into the air. You try to land, but there is no solid ground, only liquid rock. Your spacecraft touches the surface and immediately begins to sink. The lava is thick, viscous like honey, but it glows with unimaginable heat. The temperature is unbearable. Your instruments fail. One by one, the ship's hull begins to melt. You try to lift off, but it's too late. The lava has already consumed you. Lava worlds aren't just scientifically interesting, they are terrifying. They show us what planets look like in their most violent state, right after they're born. Before they cool down, before they can form solid crusts, and long before life has any chance of existing. These worlds are primordial, frozen in time at the moment of their creation, when everything was molten and nothing could survive. But here's what makes lava worlds even more fascinating. They might be able to trap massive amounts of volatile elements, things like oxygen, carbon, and even water. A study published just last year found that a lava world 4 times more massive than Earth could trap over 130 times the mass of water in all of Earth's oceans, and about 1,000 times the amount of carbon in Earth's crust, all locked away beneath the magma ocean. This means lava worlds might be reservoirs, storing the fundamental building blocks of atmospheres, and potentially even life, for billions of years, waiting until the planet finally cools, solidifies, and releases those elements back to the surface. Lava worlds also tell us about our own planet's past. Earth itself was once a lava world, 4.5 billion years ago, right after it formed. Our entire surface was molten, a global magma ocean. It took millions of years for it to cool, to form the first solid crust, and eventually, the oceans we know today. Every rocky planet goes through this phase, but most cool down. Lava worlds don't. They stay hot forever because their stars won't let them cool. There's something deeply unsettling about these places. They are planets where the ground is liquid, where the sky rains molten rock, where nothing solid truly exists. Just endless, flowing magma. And they aren't rare, they are common. Half of all rocky exoplanets we find might be like this, which means lava worlds aren't the exceptions, they're the norm. Earth is the exception. We were lucky. We cooled down. We solidified. We developed oceans and eventually life. But most rocky planets didn't get that chance. They stayed hot, molten, and uninhabitable forever. Thank you for watching the Oceans of Fire with us. Until next time, keep watching the dark.